Hi there, so my name's Chris and I was lucky enough to get the opportunity to complete a UROS project back in this summer. First of all, thank you for watching the recording of the presentation. So my project is titled Paleofire Record, or the Paleofire Record of Lincolnshire in the late Holocene. So first of all, I'm just going to give some acknowledgements and then go into the introduction to the project, introduce the study site and the aim of the project, look into the methods that I used, discuss some results and a little discussion, and then just give some concluding remarks regarding the project and future research. So first of all, some acknowledgements. So I'd just like to give a quick thank you first and foremost to Nguyen Grace, who is the UROS lead. She's been a terrific help through the project, so just a big thank you for all the hard work there. A quick thank you to Dr. Joseph Harwood, who's the senior technician, and he's been responsible for lab work and just lab access and making sure the equipment's there, so a big thank you to Dr. Joseph Harwood for that. And a really big thank you, last but not least, to Dr. Kristen Beck, who was the supervisor for this project. Again, she's been amazing throughout with support through the project and has been there step by step. So a big thank you, Kristen, for all that help. So just an introduction to the project. So what is the project really? So paleofire is this term for really ancient fire, so ancient wildfires. And we've got this idea that wildfires are more common, they're increasing, and they are this increasing concern with anthropogenic climate change. And anthropogenic climate change is just climate change that's induced by humans. So human activity is a concern for why we are seeing more wildfires, and they're predicted to increase in the future, and that isn't going to have positive consequences on the environment, on climate, or indeed us. So you may remember the Australian wildfires a few years ago, and indeed ones we had on the moors in England. So wildfires are increasing and we are seeing them in our lifetime, and we're seeing them on more bigger scales as well. So trying to predict and understand the impacts of future fires is quite difficult from an observation perspective. So, we can't just look into the future and assume wildfires are going to increase and therefore we need to manage X, Y, and Z. We have to have something behind that, some evidence, some sort of past trend. So when we look at understanding long-term fire trends from the past and understanding their impacts, that can then help us predict future fires and manage the environments that may have been in the past or may well be in the future experiencing fire. So we look at the past, we look at the fire records, in the past we look at the climate records, and then we make those decisions on understanding that trend and going, okay, it is likely this is going to increase or decrease, or this area is more susceptible than that area, etc., etc. And the project also takes into account this North Atlantic Oscillation. So it's referred to NAO throughout the presentation. And this is really an important hydroclimatic driver in Lincolnshire, and it's important for landscape management. And we come on to that just a bit more later on. But the project focuses on the UK, and it focuses on a site specific within Lincolnshire. And the reason we look at the UK is that the UK is heavily influenced by the NAO. So it does have a substantial effect on the European climate by really controlling, in layman's terms, controlling the position of the storm tract over the North Atlantic, hence why it's given the name North Atlantic. And that position of the storm tract subsequently controls changes in things like precipitation levels, temperature, etc., etc. And as we well know, higher temperature, less participation, more wildfire, environment friendly. So we do have the idea of a positive NAO and a negative NAO, and the hypothesis here is we're trying to say a negative, a negative NAO period was present at the time of the history of the core that I've taken. And all I mean by a negative NAO is that it was a wet and mild winter, so a winter over the southern and eastern parts of Europe, and dry winters over the northern parts of Europe, so where we are. So that being said, the aim of the project really was to address the following: whether macroscopic charcoal presence aligns with historical climatic events, and if we see similar patterns in charcoal with NAO. So charcoal is a really good indicator, it's a really good proxy on fire history. So material burns, leaves charcoal, and when we say macroscopic, we can have different sized charcoal pieces. So we have more larger charcoal pieces, more smaller pieces, and we come on to that a bit later on. But we can look at the amount of charcoal and try and determine what was the likelihood of a wildfire occurring in this area, and more research can be done to determine, was this a wildfire, was this just a fire on some moors that was human induced from agriculture or burning, and we can look more into that. But this project doesn't go that in depth. And the rationale behind the project was there's little to no records of paleo fire in Lincoln within the late Holocene, which is the time I address. So the aim of the project was to try and just address that gap a little bit within the paleo climate work, and particularly those fire histories within the East Midlands. So just a quick introduction to the site. So here you can see what I've called KB CRRC 2001. So that's the core name and that's the core site. And you can see there we've zoomed in to the area of Crowles Moor where the core was taken. And that's towards Scunthorpe. And here you can see the University of Lincoln. So I've just added the University of Lincoln here just to show a comparison of the distance. So we're not too far away from said site. And the reason this site was chosen was Crowle Moor is part of the Umberhead Peatlands National Nature Reserve. So that is one of the richest lowland peat vegetation areas in the north of England. And we do later discuss the importance of peat and why that was chosen. So charcoal is reserved well, should we say, within peat. So it stays when peat forms, charcoal stays as it is. It doesn't deteriorate or anything like that. So it stays as it was back all those years ago. And Crowles Moor is quite important actually, as peatlands play really an essential role within the biosphere because they are the natural largest carbon stores. So by carbon store we just mean storing carbon from the atmosphere. So peatlands are quite a key role. So I'm just going to move on now to the methods that was used for the project. So here we can see just a bit more information about charcoal. So the charcoal preserves in natural archives can be used to determine historic events. So by natural archive, peat, as I just previously mentioned, is one of those. It's a natural archive. So charcoal preserves well in those archives. And these preserves, as I alluded to earlier on, can be small versus large, and those can inform us about local versus regional fires. So more larger fragments of charcoal, if we find more larger fragments, we're going to assume the fire was more local. And if charcoal fragments are more smaller, we're going to assume the fire was a bit further away. And the reason for that, and this is where the NAO comes into it a bit more, is that with more wind and more storms, it's this idea that finer charcoal fragments can be carried further from the origin of the fire. So first of all, it was about taking a core. So this core was already extracted for me by Dr. Kristen Beck. So a core which was 344 centimetres in length was extracted, and figure 1 was just the previous map slide, and I later then subsampled and processed the core, and we'll later come on to a figure that demonstrates the processing morphology. But there you can see that is the core. So straight from here, from 0 centimetres all the way down, so at the top, so at surface level, all the way down to 344. So just down here being the bottom. So it is quite a long core. Obviously it doesn't look long there, but if you put each piece next to each other, it is quite long. And you can see vaguely just some changes within the colour from the top straight to the bottom, and those are things that we note as well. So we do note, when we take a core, we note the colour, we notice any obvious changes, we notice any changes in vegetation, you know, and all those different things can help to determine the period of time within the core, and so on and so forth. And it is worth noting that charcoal analysis from natural archives is widely used for reconstructing past biomass burning on ecosystems. So it is widely used, but there's little record of it within Lincolnshire first of all, and within the late Holocene. And the growing use of this charcoal analysis, so more and more analysis is being conducted with charcoal and charcoal as a proxy, reflects this heightened interest within paleoecological work, paleoclimatic work, and considering fire as an ecosystem process operating on long-term and short-term scales. So, that being said, we then examine the core. So as I've just alluded to, you've seen the size of the core. So we measure the core. So this is an image taken from another project. And notice any obvious changes. As I mentioned, take notes of depth, sediment colour, visible microfossils, all those sort of things. And all that information, as I say, we can put on a database for future use and refer back to when we're analysing the data. So, processing charcoal. So the nitty-gritty part of this project was charcoal. So we've logged the core, and now we're starting to process the core. So here you can see figure 4, which demonstrates the process of subsampling, processing and counting of charcoal. So essentially we use what is called a volumetric subsampler and a spoon, nothing too fancy, to obtain, or what I obtained was a 1 milliliter sample from the desired depth of the core. So for 344 centimeters, I took a sample starting at 0 every 5 centimeters, and that gives a relatively decent window when reconstructing this environment. So every 5 centimeters in depth, we can see X amount of charcoal, and we can put together this reconstruction of the past environment. So we place the sample then into a beaker, which you can see here. So we would have placed the sample in the beaker, covered it with bleach, so just make sure the sample is just covered with bleach, and then we leave it for a week or two. And the reason we leave it for a week or two, is to just allow for the macroscopic charcoal to be separated from all the other detritus that's in the sample. So once using the sample, we can empty it into a 250 and a 125 measurement sieve and gently wash with water for a couple of minutes. So that just, again, it gets rid of the bleach. We don't want bleach in the sample under the microscope because then that can hamper the results. We want clear water, we want the sample clean so that we can analyse it under the microscope. And once washed, we transfer that sample from each sieve into a Petri dish, and we use deionized water again to clean the sieve. So then we place the sample, so we're just here, place the sample under the stereo microscope, and we place it at the 30 measurement magnification, and we start to count charcoal pieces using a tally counter. So you can use pen and paper if you wish, however, we did start with that, and then we noticed it does become difficult to keep track, so that's a caveat. However, with a tally counter, you can multitask and count the charcoal, but also count it on a tally counter as well. So you're not worrying about moving away from the microscope, jotting a number down, going back and recounting or losing charcoal pieces. So then we note the depth. First of all, we note the depth of the sample. So as I say, I took my first sample at 0 centimeters, so I noted 0 centimeters, and I counted the number of charcoal particles from both the 250 sieve and the 125 sieve material. So each Petri dish, so one Petri dish had 250 the material, one had 125, both were counted and noted. We then return the sample from the Petri dish back into the beaker for archiving, and we repeat this process again and again. So this is just after bleach has been added and we've shaken. So we've got to shake the sample and allow for that charcoal to be separated, and 2 weeks later it'll look like this, or a week or two later, sorry, it'll look like this again. Once we return the sample, we've got to think the Petri dish is filled with deionized water, so the beaker would be filled and it'd be clear. And we keep those for archiving as well, because there's other studies that can be done in the future with the charcoal. So I just wanted to add an example really of what charcoal looks like under the microscope. So you can see in this example here, it's not quite obvious. There's a lot of other material in this sample. So it's how do you define what charcoal is? How can you tell? And quite often it just involves a little cocktail stick and poking. If it's charcoal, it'll break apart. If it's not, if it's a rock, it won't break apart. And obviously if it's living material or things like that, then you'll be able to tell. So sometimes it's not always clear and it takes a bit longer to be able to see the charcoal. And then other times you get these sort of images where each black dot roughly is the charcoal, so you can see there. And what we add under the Petri dish is just a square grid. And that allows us to count the charcoal more easily because we can follow the grid left to right, left to right. Sometimes we get an image like this where there are other particulates in the sample that isn't charcoal, and it can make it quite difficult. But again, it's just using that cocktail stick. And sometimes, unfortunately I didn't get a photo of this, sometimes if you think of this middle photo, sometimes there can be thousands of particulates of charcoal, and that would just look like a black circle. So it does take a lot of time sometimes to count the charcoal pieces, and it takes a lot of time to be meticulous and make sure we've not missed squares or pieces of charcoal, because we don't want to skew the results. So I'm just going to bring on to really the results and a little bit of discussion. So essentially, by analysing past environmental reconstructions, we can identify historic trends and peaks in fires. So we can also try to align those with prehistoric events. So this figure here was created as a result of the project. So we can see here the accumulation rate of charcoal. We can see here the relevant calibrated age, year BP, and this black line represents the NAO index. So figure 7 essentially shows the accumulation rate of charcoal from the core with the corresponding age and with the addition of NAO data to complement charcoal findings. So the yellow boxes there highlight interesting peaks of either NAO below 0 or high charcoal accumulation and a potential relationship. So I've highlighted areas that I find interesting. Other academics may find other peaks interesting, but the idea was, okay, let's look at the NAO index. What is below 0? Have we got any peaks below 0? And we have one here, one here, one here, and one here. So whilst there are other little peaks below 0, these are the ones that I want to focus on more, and those are the ones that I found more interesting. And equally, I wanted to highlight the areas where charcoal was peaking the most. So again, in this section and in this section. So there are other little peaks, but those two were quite of interest. So that showed to me a potential relationship with NAO being lower and charcoal accumulation rate being higher. And we can also see this green box where I suggest a peak in charcoal and where I've tried to align it with a prehistoric event. So around 4,200 years ago, so 4.2 Ka, there was a global period of abrupt climate change, and that became known as the 4.2 Ka event. So with a charcoal peak, that was rather interesting to see, and then align it with this NAO data. So is there a possible relationship between the charcoal accumulation rate there and also the 4.2 Ka event? That would need more investigation, but it was a preliminary identification, a preliminary idea, which I found quite interesting. And the patterns really of this charcoal, as we can see here, appear on first glance to reflect really an negative NAO period. So the data here suggests that these charcoal peaks are associated with a negative NAO period, so subsequently causing a drier period in Lincoln. And the record really saw more positive NAO periods, meaning less drier periods in eastern England, which is indicated by this NAO index. And again, I've just highlighted some key areas where there were some peaks, of which I found rather interesting. And of these, we can see I've chosen 4 really, between 200. I've chosen 4, sorry, between the year 250 BP and 3,500. So I've chosen 4 charcoal peaks. So 1, 2, 3, and then this NAO peak here. And really, half of those, so 50% of those occasions, saw high correspondence with charcoal peaks. So with NAO peaks, sorry. So during the time of 2,250 roughly, so this area, to today, this NAO data appear to indicate wetter conditions. So less charcoal down here, from present day back to 2,000, 2,500 years ago, and this associated NAO data would indicate wetter periods, so less charcoal because there's less opportunity for wildfires to break out, essentially. And again, I've just increased that there slightly just so you can see this peak a bit more here at 4.2 Ka, this other peak, and more the NAO as well. So we've just identified that the NAO data from today and up to 2,500 years ago indicates a wetter period, and thus the associated charcoal recorded wouldn't indicate a said wildfire. That's not necessarily to say there weren't any fires, because as we know today there have been, but there hasn't been huge fires. There could have been little ones, but this is just the accumulation rate. So I just want to give a little conclusion, just a concluding remark. So as we discussed earlier, there is a gap in paleoclimate work, and particularly fire histories in East Midlands. So further research would help to address this gap. So this project hasn't addressed the gap fully because there is such a wide scale of work to be done. We also mentioned that the growing use of charcoal analysis reflects this heightened interest within the paleoecological community, and really this idea to consider fire as an ecosystem process that operates both on a long-term and a short-term scale. And there's also a need there a need really by environmental managers to understand prehistoric fire regimes. So this research would be handy for a company such as the Lincolnshire Wildlife Trust. So to conclude, the charcoal at Crollmore follows closely with a negative NAO pattern, likely driven by past dry conditions. So that was the conclusion from the project overall. And as mentioned, further research could be undertaken to analyse more cores extracted from across Lincoln/Lincolnshire to create that regional paleo fire reconstruction, which would give a more precise, more realistic reconstruction than just the one site. And here I've just provided the references that I've used throughout. So thank you for watching the session. I hope you've enjoyed the project, and if you do have any questions, please feel free to get in touch. Thank you.